So we're starting with 2,3-dihydroxybutane, and that has 2 stereocenters within it. And here's just one example of how we could draw it. So this compound is actually meso because there's a plane of symmetry through it in which this methyl group mirrors this one, this hydroxyl group mirrors this one. If I had drawn the hydrogens, those would mirror one another as well as these 2 carbons. Meso just means that the enantiomer is the exact same compound. So if we flip both of these stereocenters to make them look like dashes, just for instance, OH, this is another way to potentially draw this compound, OH. If we flip this 180 degrees within the plane of the screen, you get the exact same compound. So these 2 compounds are exactly the same. Even though I switched both stereocenters, it's the same compound. So this compound doesn't have an enantiomer. Its enantiomer is itself. Therefore, it is meso. Another way you could draw this compound is to have one of the alcohols coming towards you and one going away. And we could draw the enantiomer of that, which I would suggest you try and build if you can't see why these 2 compounds are not superimposable. They are actually mirror images. So this compound is a mirror image of this one. You cannot lay them on top of one another no matter how much you try and rotate them. Please play with that if you don't see it. These 2 compounds are enantiomers. This is a diastereomer to these 2 because you change one stereocenter, for instance, between these 2, but not all of them. So a diastereomer is where you change at least one stereocenter, but not all of them. So these are the 3 ways you could draw that compound. This one doesn't count because it's the same as the first one by symmetry. For the next compound, we can draw now 4 stereoisomers. So now we're just changing out one of the hydroxyl groups for a chlorine. So just starting with the first one I've done, both wedges. We could do one on a wedge, one on a dash. We could do both on a dash. And we could invert this one to have the alcohol on a dash and the chlorine on a wedge. Now let's look at the relationship between each of these compounds. Just based off of practice, I can tell you none of these compounds are superimposable, aka none of them are identical compounds, and none of them are meso. The easiest way to figure out if you have a meso compound is to look for a plane of symmetry. If you do have a plane of symmetry through the compound, it is going to be meso. So this compound, we cannot draw any planes of symmetry, so it's going to have an enantiomer as well as probably diastereomers. And the mirror image of this compound is this one. So these 2 are enantiomers. Because if I put a mirror between the 2, or one on top, one on bottom, you would get this compound. You've inverted both stereocenters. This is the enantiomer of this compound. Every other relationship is going to be a diastereomer. For instance, these 2 are diastereomers. And you can easily figure that out, again, because you change at least one stereocenter, but not all of them. So here the alcohol remained the same, but the chlorine's stereocenter has flipped. So they're not mirror images, they are actually diastereomers. These 2 are also diastereomers to one another. These are diastereomers to one another. These are diastereomers to one another. So these 2 are enantiomers. I apologize. These 2 are enantiomers. These 2 are diastereomers. These are diastereomers and enantiomers.